So hi, today I'll be going through MAT 2023, which is basically the latest MAT. And as a pure math student, I will only go through questions 1 to 5 because that's what we're required to do. And so for question 1, it's basically an MCQ, so I'll be going through the MCQ now. Alrighty, so here the first question asked to find um each of these numbers is close to an integer, so which is closest to an integer. So we consider each of these. So 2 beta is equals to log 10, 9, and then 5 alpha plus beta equals to log 10, 32 plus log 10, 3, which is log 10, 96. And intuitively, you think that this is closer to 100 than this is closer to 10. So you could check out option A and then C alpha plus 2, whatever that is, log 10, 98. And then D, 2 alpha plus 5 beta equals to log 4, 2, 4, 3, 10, 9, 7, 2. And then E is 2 alpha plus beta plus gamma, which is log 10, 4 times 3 times 7, 84. And that isn't really close here. So now we look at like 98, 972, and 96. And 98 is closer to 100 than B is, so it crosses out. And you know that 98, like log base 10 98 plus 1 is equals to 980. So this makes it closer to an integer than D is, so the answer is C. Okay, so cool. Moving on. So exactly one of the following numbers is a square number. Which one? Well, this is a square number minus 1, so this can't be the case. And your square numbers can't end with 3, so it can't be B either. And then there is D, but square numbers end with 025 instead of 035, so D can't be the case. And then for E, it's a power of 10 to the power 3, so it also can't be the case since it has to be an even power. So C is the only possible option by elimination. I personally think this year's MAT, the MCQ wasn't as tricky as compared to last few years, so that's a plus side because I usually callous some MCQ marks. So the area of the large circle is 10 times the area of the small circle. So this makes like, so you're supposed the radius is like 1 or something. And then this is 1. And this is like root 10. This is root 10. So you know that that's like side length 1. So this is root 10. And then it's like 45 degrees. So that will be like 1 plus root 10 divided by root 2 x plus x plus root 10 x equals to 1. So this gives 1 plus root 10 plus root 2 plus root 20 x equals to root 2. So x is equals to root 2 over um 1 plus root 10, 1 plus root 2. And then they ask for the sum of radii of the circles, which is basically 1 plus root 10 x equals to root 2 plus 1, which is like root 2 minus 1, so that's 2 minus root 2. So the answer is B. Okay, moving on to D. D is honestly a pretty ugly whack. So firstly, case 1. Uh so minus 3 equals to 2. Case 2, minus 3 equals to negative 2. So then the square is equals to 5 and the square is equals to 1. So there is plus root 5 minus root 5 minus 2 equals to this, minus 2 equals to this, and also minus 1, 1 and negative 1, minus 2 equals to this, plus 2, both of minus 2 equals to this, minus 2 equals to this. So I'm writing in a very abstract manner so that all can save some time. So minus 2, so then x squared minus 1 squared equals to 2 plus 5. X squared minus 1 squared equals to 2 minus root 5, which is less than 0, so you strike out this case. And x squared minus 1 equals to 3, or x squared minus 1 squared equals to 1. And then for this case, x squared equals to, x equals to x equals to 1 plus minus 2 plus root 5 and plus minus this entire thing. And oh, you realize that it can't be minus, so it should only be plus, because otherwise this thing will be less than 0. So it's plus. That use two solutions. And here, x squared minus 1 equals to 1, or x squared minus 1 equals to negative 1. So this gives x equals to 0, or x equals to plus minus root 2. And similarly, just use two solutions. So the answer is C, because it's like 2 times 3 plus 1 solutions. Okay, so moving on. Less than 3 to the power of 10, but not powers of 3. So it's 1 plus all the way onto 3 to the power of 10 minus 1 minus 3 plus 3 to the power of 1, 3 to the power of 2 plus 3 to the power of, less than. Well, you don't have to include 3 to the power of 10 here, so it'll be 3 to the power of 9. Okay, so that will be 3 to the power of 10 times 3 to the power of 10 minus 1 divided by 2 minus 3 to the power of, oh no, 3 to the power of 10, 3 to the power of, well, this is confusing. 3 to the power of 10 minus 1 divided by 2, and so the answer is 3 to the power of 10 minus 1 squared divided by 2, so the answer is C. No, the answer is A. The answer is A because, yeah, the answer is A. And moving on, now they ask for the coefficient in this where it's x to the power of 12. And so basically, your x to the power of 12, it's sort of like 1 minus 4x squared to the power of 5 plus 1 plus 4x squared to the power of 5 equals to 1 minus 16x to the power of 4 of 5. So x to the power of 12 is sort of like 1 plus 5, 1 to the power of 5 plus 5, 1, 16 for 1 plus. Yeah, something like just use binomial and you expand it, so it isn't that tough. Yeah, and this gives like x to the power 12, so this is 10 times 16 to the power 3. So this is 2 to the power 13 times 5. Oh, but it's negative, so the answer is A. And so moving on to G. So in G, it says that each equation here has a repeated root. So you know that the discriminant is equals to 0. Hence, B squared equals to 4AC and C squared equals to 4AB. So now you consider what A squared minus 4BC is. You know that here BC can't be equals to 0, so BC multiplied together is not equals to 0. So here you have like A squared equals to 1 over 16 BC by solving these two equations simultaneously, and then you obtain that this is equals to negative 63 A squared, which is less than 0. Hence, there are no real roots, so the answer is A. For question H, um, okay, largest area. This question wasn't really pleasant, so I feel that you could use algebra, like you could use some calculus, to get like say you because these are like obviously two same sides. So it's all like this one's x and this one's x and this one's like 100 minus x squared. So you multiply things together, you get 2x 100 minus x squared, a root 100 minus x squared divided by 2, which gives you x 100 minus x squared. And you basically try to differentiate this. So after differentiating, you get root 100 minus x squared plus x times half 100 minus x squared negative half equals to 0. So, well, 100 minus x squared equals to x over 200 minus x squared. And that gives like 400 minus x squared equals to x squared. And so x squared is equals to um 20. Yeah, x squared is equals to 20, and so you solve for 2x. So 2x is equals to 4 root 5. And root 5, you kind of like got it, and it's around like 2.3, if I'm not wrong. So then that will be closest to um, hold up. Okay, so 100 minus x squared x. Oh, nah. So here half 100 minus x squared forgot to differentiate the thing inside, so that's negative 2x. And that gives like 2 that gives x squared. So 100 minus x squared is x squared, so x is equals to 5 root 10. So there's like 2 root 10, 10 root 2, which is around like 14. So the closest option to it is like D. So the answer is D. And you also note that it's somewhat like when it's the smallest, it's somewhat like 5 root 2, 5 root 2, 5 root 2. So it's like 45 degree and 45 degree multiplied together. So intuitively, you sort of know what must be the case, but you just go the other like the deeper step to go check whether it's the case or not. Polynomial has degree 3, p0 equals 0. And well, for this case, you basically just assume like it's equals to ax3 plus bx squared plus cx plus d. So this is equals to 0. Then you have a plus b plus c equals to 1. 8a plus 4b plus 2c equals to 2. 4a plus 3b 2b plus c equals to 1. So 3a plus b equals to 0. It has a repeated root at x equals to m with m greater than 0. So it's like x a x squared plus bx plus c equals to 0. And this repeated root is giving you b squared equals to a for AC 5. So you let like b equals to negative 3a and 9a squared equals to 4ac, so c is equals to 9 over 4a. So well you sort of like sub everything back, a minus 3 plus 9 over 4. A equals to 1, which gives you 1 over 4, A equals to 1, so A equals to 4, B equals to negative 12, C equals to 9, and for M the answer is 3 over 2. Okay, for this graph, because like take note of this, so you sort of like intuitively can guess that it's like made out of blocks of little rectangles all made up together. So so it's something like this. Each time twice the width of before, but then half the length. Oh no, four thirds the height of the previous one. So something like this. So the total area is like a geometric sequence of one. Cause like this is like the um it's like it's like half the half the width and four thirds the height. So it's like two thirds. So that is like 1 plus 2 thirds plus 4 over 9 plus all the way onto that. And then you add up everything together and you get C. Okay, let's graph it out to check whether your results are correct. Yeah, and moving on to question 2. So sketch the graph of x plus 1 over x. Label any turning points. So the graph of x minus 1 over x plus 1 over x, it's a quite standard problem. So turning points are where 1 is at x equals to 1 or x equals to negative 1. So yeah, you get x equals to 1 after you take like 1 minus 1 over x squared equals to 0 and x equals to plus minus 1. So you have to have this in your working as well to make sure you've gone the extra step of looking at what the turning points are. And the asymptote is that x equals to 0 and y equals to 0. Yeah, so for this question, show that this is a very simple one question, so it's x squared plus 1 over x squared, which is pretty easy to show. And then for P3x in terms of P1x, it's also some really classic Math Olympiad question that usually appears in the junior level. So you get like x3 1 plus x3 plus 3x plus 1 over x. So this is like P1 cube x minus 3p1x. And then for like, okay, so I'll erase everything. for IV, it's also quite a classic, I guess, because you look at this and you realize that it's symmetric about what you want to find. So you divide everything by x squared. So you get x squared plus 1 over x squared equals x plus 1 over x minus 10 equals to 0. So this is P1. And then like this is like P1x squared minus 2. So P1x plus squared plus P1x minus 12 equals to 0, which gives you P1x plus 4 minus P1x minus 3 equals to 0. So x plus 1 over x equals to negative 4, or x plus 1 over x equals to 3. So basically I'll just give you until this and you can solve for x yourself. So for x. Okay, and okay, same thing for question I, except for this time you realize that it's probably not so nice because the power here is not even. So naturally like you will motivate yourself to do something that kind of changes the entire like formation of this equation and you realize that x equals 1 is the solution. So why not you factorize x minus 1 and take out like what everything is. So it's like 6 plus 1 plus 3x5 plus 3x yeah, something like this plus minus 2x to power 4 minus 2x squared and minus 9x cubed equals to 0. So same thing, you can divide everything by x to the power of 3, and then you get like x to the power of 3 plus 1 over x to the power of 3 plus 3x squared plus 1 over x squared minus 2x plus 1 over x minus 9. So this is like p1x cubed minus 3p1x plus p1 3p1 squared minus 6 minus 2p1x minus 9 equals to 0. And then you try factorizing this thing again. Oh dear. Okay. So seems like it's a little bit of mishap. So um back to this. So you try factorizing this and you get like p1x plus 3 p1x minus plus minus minus root 5 p1x plus root 5 equals to 0. So you look at everything again and you realize that, so it's asking you to find what x is when x plus 1 over x is equals to negative 3 or plus minus root 5. So once again, I leave the exercise out to like my audience. Okay, so moving on to question 3, which is also a very tedious problem. MAT problems are usually very tedious. It requires you to have like accuracy and speed at the same time. So without differentiating, write down the maximum value of cosine 2x plus 30. I feel that it should be quite obvious that it's 1. Again, without differentiating, find the maximum value. So that's like asking you to complete a square. So you let this be like y, you let this be y as well. So it's like y minus y squared equals to half 1/4 plus y minus y squared. So plus quarter, that's like 1/4 minus y minus half squared. So the answer is half, and that's possible when y equals to half, which is obviously within the range itself. Okay, so this time it asks you to find the maximum value of this. And so once again, you realize that it is like this first equation raised to the power of 5. So the maximum value occurs at the same value of y itself. So here it is. So it's like 1/4 raised to the power of 5. So it's like 1/1024, which probably isn't too smart. I don't know why this is 4 marks, but I guess MAT has its ways. Okay, and now for question 4. Um, well, this time it's a bit different. So you sort of have to realize that, oh, this thing is also like this thing is like sine squared 3x minus 60, and this thing is 3 minus sine 3x minus 60. And so this is like you sort of like raise both to um the power of 6, the power of 8. You raise everything to the power of 8, which is slightly different because for like the previous questions, these are all odd. So now you have to take note of something like slightly different. It's like essentially this is like u, this is 3 minus u, right? So u3 minus u sort of follows the graph like this. It crosses through the origin, and then the function takes like extreme points at the end points at like okay, because like it's restricted between -1 and 1. So it's sort of not like what you have before whereby it has like a maximum value at half because it's like always increasing. So you notice like the values are at its endpoint only, and that's what matters the most. So at -1, this thing is equals to 4. At 1, this thing is equals to 2. So the maximum value is then 4 to the power of 8, which is 2 to the power of 6. And that's the answer. Okay. And now for question 4. Once again, very tedious problem. I also don't know why MAT problems are always so tedious. But yeah, find the coordinates of B in terms of A plus D. So B lies on L so that AB is a fixed positive number D. So like L is a normal to parabola at A. So y prime equals to 2x or and half. So that's like x, and that's the tangent. So at that point, the equation is like y minus half a squared equals to 1 over half 1 over a x minus a. So while b, you let it be like, say something like c and d. So b has to have its points lying on these um lines. So d is equals to 1 half 1 over a c plus 1 plus half a squared. And then it says AB is a fixed D, so oh, that's probably not so nice to use. Yeah, AB is a fixed D from here, so you have like C minus A squared plus D minus half A squared equals to no, I shouldn't use D, sorry. I use like use like M and N, so it's slightly better to express. Because if I use D, then it's a repetition. So here, um, you sub m and n in, so you have n minus half a squared equals to negative of 1 over a m plus 1 plus half a squared. And so, I moved that thing over. So it's like this. So you have like n minus a, n minus that thing equals to d squared. And so n minus a squared plus half 1 over a m plus 1 squared equals to d squared. And well, I mean, you basically can realize that this is like m minus a squared 1 plus 1 over m squared d squared. So if you take everything, so you get like m equals to a minus ad 1 over a square root of that, and n equals to a squared divided by 2 plus d over square root of 1 plus a squared. Yeah. So the question here shows that if B lies on a parabola, then we must have this equation. So if B lies on the parabola, then you know that like this y squared here should be equals to half x squared. I mean, basically it's just whack, honestly. This problem here is just not really nice whack, so I don't really want to show how the whack is supposed to be done for II since it's not that smart in my opinion. But yeah, I'll move on to III. So once again, this is whack. Okay, so III. Um, let T equals to A squared. So you have uh you can divide both sides by E squared and then raise both sides to the power of 2 to the power of 3. So D 2 to the power of 3 is equals to 2 2 to the power of 3, 1 plus A squared divided by A 4 to the power of 3. And so this is equals to like where you sub in like t equals to a squared. So ft here that's equals to 2 to the power of 3, 1 plus t over t 2 to the power of 3. So it's 2 to the power of 3 t plus 2, 1 to the power of 3. Okay, so for IV, find the minimum value of ft. So find the minimum value of ft, you basically just I mean, it's nothing too complicated or anything. So you basically just like differentiate it. So you get like 2, 2 over 3 t raised to half 5 to the over 3 plus 1/3 t 2 to the power of 3 equals to 0. So t equals to 2. So ft here thus equals to 3. So then what is D? D has to be like greater than or equal to some value. So if D is less than 3 root 3, then D is lower than a minimum, and there's no such value of A. So it has to be greater than or equals to 3 root 3. Okay, now we move on to question 5, which is also the most simple problem because it's Fibonacci. So F3 is equals to 2, F4 is equals to 3, F5 equals to, well, 5. And then like using the equation repeatedly in terms of n, how many additions do you need to get to Fn? So you kind of do need every single addition to get to Fn. So it's like n minus 2. Because you can kind of induct, you need like one addition to get to F3, and F2 plus F3 gives you the other addition. So this is like 2, this is like 1, so like n minus 2 for every single one. And okay, here it asks you what are the values of S1 and S2. So valid sequences of length 1. So S1 is basically equals to um either 0 or 1, so it's 2. Then S2 is equals to or like 0, 1, 1, 0, or 0, 0. So S2 is equals to 3. Well, one can't be the case because it can't be consecutive. So then it says that by considering the first element of the sequences show that it satisfies the Fibonacci equation. And I think that this one shouldn't be too complicated because you observe the sequence, it's like 5 and like so it gets to 8. So you kind of realize that it's basically like Fibonacci sequence, but like you sort of shifted by 2 first. And so this part I won't go through like too much because you can basically just induct to get like this property that it's Fibonacci, that's all. Okay, for question part 5, I did think about this for quite some time before I got to the actual solution. So you do what is they ask, you consider a valid sequence of 2n minus 3. So you know that if the n minus 1 like element is 0, then so you can add like like either 1 or 0, both works. So that's like so you can add either 1 or 0 at like the nth position since it doesn't really matter. But if like the nth is like 1, then the nth minus 1 position is must be 0. And you notice that the one before it, n minus 1, is also like 0. So here it's like fn minus 1 squared possibilities, and here it's like fn squared possibilities. Ah, no, no, no. So no, here no, we don't consider fn so quickly first. Here we consider the s basically like what are possible sequences to fulfill this condition. So that gives like s this one is n minus 2, this one is like n minus 3. So you then sub it back to like fn, and then it basically fulfills the solution. Okay, for question VI, show this. Okay, basically just induct, just induct. Yeah, just basically induct. You show for f2n plus 2, and then you can basically just like you get strong induct from f0 all the way to f2n, and then you can get f2n plus 2. Use the Fibonacci rule. Okay, so for VII, I honestly think this question is slightly trickier than the rest. So VII, we can compute f2i and f2i minus 1 for I equals to 2 all the way to k minus 1. And then you use like f2k and f2k minus 1 to get like f2k. Okay, because like you can use both. You can use this, you can use E. So for all of these like pairings, you need like 3 multiplications. Because like you need like 2 squares and 1 multiplication. If you just look at E. And then you need 2 additions. So that's like 5 operations for I equals to 2 all the way to k minus 1. And then, oops. So, and then that is like 3 operations for I all the way from 2 to k minus 1. and then 3 operations for f2k. So that is like 5k minus 2 plus 3 equals to 5k minus 7. So I mean, it's just like any sort of like reasonable answer that works, but this is just one of them. So it's not like the least number you need. You just have to prove that it's somewhat sensible. And this problem sort of just like irked me for a while. But other than that, that's like basically the end of MAT for pure math students. Sorry, excuse me. For pure math students.